Alright, in this video we're going to take a look at multiplying and dividing radicals as well as rationalizing the denominator of fractions when we're dealing with radicals. All of this is just an introduction into what we will be using for some trig stuff and some right triangles. But oftentimes we find that the hardest part for the students is not actually the right triangles or learning the geometry aspect, but it's the algebra part. So we're going to spend a day and review some algebra, multiplying, dividing, and rationalizing. So let's take a look at this first one. We're supposed to multiply together the product of 10 and 6 root 80 and then round to take it to simplest radical form. So if I were to write this out, 10 times 6 root 80, right? This is roughly what I've got mathematically. Let's start with the multiplication. So remember, when we multiply, we're going to multiply integers with integers, radicals with radicals. So 10 times 6 becomes 60, and then I've got root 80. And we did this earlier in the year. We did some reducing radicals, but we'll double check to make sure we remember how to do that. So root 80, remember what we want to think about is with 80 is pulling out a perfect square. All right, so I know for sure a perfect square. Our perfect squares are 4, 9, 16, 25, 36, 49. Okay, let's just start by pulling out 4. We know 4 is a perfect square, right? So that's one perfect square, and I end up with 20. And actually, it looks like I could pull out 4 twice, 2 perfect squares of 4. All right, so let's just do the first one here. So root 60. Or 60 times. Now, a perfect square is 4, so the square root of 4 is 2, so that's what we pull out in front of the radical, and then we would have root 20 here. And so I get 120 times root 20. And once again, we show here that we can pull out another perfect square of 4, and I would get, again, 120 times 2 times root 5, or a final answer of 240 root 5. All right, we'll go ahead and submit that. That checks out. And notice they actually broke it into a perfect square of 16, okay? But that works too. If you wanted to do a perfect square of 16, that would save you a step. All right, now let's look at a dividing problem here. Now this, a lot of the division problems are going to be pretty straightforward. You're going to end up needing to simplify the radical at the top. So I see 216. And I'm pretty sure I could divide 16 out of this, so let's go ahead and try. I'll do this on the side here, but we could also do it in a calculator. They give you the calculator option here. Actually, let's go ahead and use the calculator option since they give it to us. So I'm going to do 216 divided by 16. 13.5. Okay, so 16 actually doesn't divide in. Okay, so if 16 doesn't work, we do know 4 is going to divide in, and I get 54. So let's go ahead and do that. So I've got, oh, sorry. I can split this up into 4 and 54. Okay, so root 216, and I'm just going to worry about the radical for right now. That's the same as 2 root 54, and I recognize 54 divides by 9. That's a perfect square, so I could divide this 9 and 6. So this is 2 times 3, which would be 6 root 6. All right, so that's what's actually happening on the top of my radical. Now let's worry about what's happening or at the top of my fraction. Let's divide out the bottom. So these cancel out, and I get 3 root 6 all over 2. So that's going to be my answer here. Now, we don't need to rationalize. We only need to rationalize if our denominator is a radical. So in this case, it is not. So 3 root 6 all over 2. Okay. And let's go ahead and submit that. Why is it telling it to submit, and it doesn't seem to want to submit? I'm not sure. That's kind of weird. All right, but that would be the right answer here. Yes, I am sure. Okay. I am not sure. Maybe I made a mistake in there. Let me think about it. Oh, hang on. No, that should be right. Yeah, okay, there we go. I don't know why it was That's weird. All right. Well, moving on. So that's going to be multiplying and dividing radicals. Let's look at rationalizing denominators, and this is where people have the hardest time. All right, this is where students really struggle. So when we have denominators that are radicals, what we need to do is we need to do something called rationalizing. And what we have to do is we have to multiply top and bottom of the fraction by the same number. That preserves the integrity of the fraction. It keeps me from changing the values. And what I need to do is multiply the top and bottom by some value that gets rid of the radical in the denominator. So in this case, so let's say we have 7 over root 7. What I need to multiply by top and bottom is root 7. If I multiply top and bottom by root 7 times root 7 is going to be 7. So if I multiply top and bottom by the denominator, this is what I get. And actually, the 7s then cancel out, and I end up with root 7. Now, that doesn't happen every time. It happens in this particular problem. But we need to rationalize our denominator to make sure that we understand what we're doing here. All right, so let's look at a new problem here. Okay, so we've got 4 over root 2. So once again, we're going to multiply top and bottom by the radical. Okay, so I'm going to multiply top and bottom by root 2. So I get 4 root 2 all over 2, and then that reduces down to 2 root 2. Okay, so every single time we're just going to go ahead and rationalize the denominator. I just think if we kind of review our radical rules, hopefully when we get to the actual geometry dealing with radicals, it'll seem a little bit easier than if we didn't. All right, let me see if I can find one more here. Okay, yeah, this is a great example. So let's take a look at this. So once again, I'm going to multiply top and bottom by root 7, right? And so I get 6 root 7 all over 7. Okay. Now this doesn't reduce down any further. This is as far as it goes. Okay. Sometimes when we rationalize, we end up with what seems to maybe be a bigger mess than before. But if it keeps the denominator from being a radical, then it actually is simpler, even if it seems more complicated. All right, and there you go. So that's going to be what you need to do this assignment. Practice up. I'm asking for a lot of practice problems because I want to make sure that we have our reps in so that when we get into the geometry, we're feeling okay.